Alright, hello and welcome everyone. Today I have some set of problems related to trigonometry. So let's get into it. So the first problem is 8 sine square x minus 8 sine x plus 1 equals 0. We have to solve this equation for the interval 0 to 2 pi. Okay, so looking at this equation, this is a quadratic equation in sine x, and we can see that we can replace the sine x by some variable, let's say u. So what happens is we can say that this is a quadratic in u now. 8u square minus 8u plus 1 equals 0. We can solve this quadratic using the quadratic formula. Let's use that. So u will be negative b, which is positive 8, plus minus b square, which is negative 8 square, minus 4 times a, which is 8, then c, which is 1, over 2a, which is 8. Let's simplify this. So 8 plus minus, this is 64, this is 32, and then 16. So this will become 32 again, 16. Now we can say we know that 32 is 2 raised to the power 5, which tells me that okay, 2 raised to the power 4, I can take that out from the square root, and it will be 2 raised to the power 2, which is 4. Then what I can do is I can take 4 as a factor, which will bring this to 2 plus minus square root of 2 over 16, and this is then 1 over 4, and then you know root 2 is 1.414, so this will be 2 plus minus 1.414. Let's simplify this. So we get 1/4 of 3.414, or when we subtract these values we get 1/4. Okay, we get 1/4 of 2 minus 1.414, which is 0.586, and we can just simplify these two once again. So 0.8, 21, 5, 3, or 0.146. Alright, so this is my u, and u was same as having sine x. So these are the values of the sine x. Now to simplify for x, we can take inverse both sides. So x will be the sine inverse of 0.853 or the sine inverse of 0.146. So let's use the sine inverse table or the some calculator to solve for this sine inverse. So this is giving, the first value is giving us 1.021, and the second value comes out to be 0.146 again. These are my x values. Now let's see how much they are in degrees. So these values when solved in degrees are equivalent to, so these are now in radians, and when you solve this in degrees, this one is I think 58 degrees, and this one is 8.42 degrees. So we know that there are some other values also for which these values will occur. Okay, so these are the corresponding values in degrees, and we know that the sign is positive in first and in second also, right? So these values are in the first quadrant. Now what we can do for this 58.6, it will be somewhere in the second quadrant also where your value repeats. So what will happen is, if we take this value 1.021, we'll get the gain value after pi minus x. So what we can do is we need to stay in the second quadrant. So what we can do pi minus x, because we can also write this as pi minus x, and then again we'll get we'll get the same result, which is 0.853. So taking the sine inverse, we'll get again 1.021. So pi minus x will be equivalent to 1.021. And then when we simplify for this x, we need to subtract this value from the pi, which tells me that okay, pi is giving me 2.12. So this is the other corresponding value for this particular x. Now we have one more, 0.146. So we can use the same concept. Now we have 0.146. So for this we'll again do the same thing. If my sin x is 0.146, that means my sin pi minus x will be the same, 0.146. And then we can take the sine inverse of this value, which again comes out to be 0.146 coincidentally. And then we need to solve for x. For the same thing, we'll be doing pi minus alright. So these are all of my x values in the interval 0 to 2 pi. Alright, so let me highlight all of the answers. So the one answer we have is this. One value of x is this. One value of x is this. And the last value of x is this, 2.99. So these are all of the solutions for our equation. So let's get to the next question we have. Number 20th is solve square root of 2 sine theta equals square root of 3 minus cos theta. And we have to solve theta for the interval 0 to 2 pi. Alright, so here we see there are two different types of functions, sine theta and cos theta. So first thing that we need to do is convert either sine theta into cos theta or cos theta into sine theta, so that we have an equation which is entirely in sine theta or entirely in cos theta. So we can choose anyone. For this purpose, we'll be using the first identity, which is sine square theta plus cos square theta equals 1. So we know that if we want to write cos theta in terms of sine theta, we can write it like this. So what I'm going to do is I'm going to replace this cos theta by this value. So I'll get square root of 2 sine theta equals square root of 3 minus cos theta is going to be square root of 1 minus sine square theta. Alright, so now we have an equation which is entirely in sine theta. Now we need to solve this. So what I'm thinking is I will take this term here and then I'll rearrange this equation and write this as this. So square root of 1 minus sine square theta. I've added this value to the both side and I've subtracted square root of 2 sine theta. So this will become square root of 3 minus square root of 2 and then sine theta. Alright. Now what I'm going to do is I'm going to take the square of both sides to remove this square root, so that I'm able to solve this equation. So then this comes out to be 1 minus sine square theta, and on the right hand side, this when opened up will get me, so this is a minus b whole square, will get a square, which is 3, will get plus b square, which will be 2 sine square theta, and then we need to do minus 2ab, so 2 times square root of 3 times square root of 2 sine theta. And then we can again we can simplify this sine square theta and this sine square theta, right? So these are the like terms that we can simplify here. So let's do that, and we can also simplify this constant and this constant. So next I'm going to take everything on the left hand side. So let's take alright, so let's simplify now. So 1 minus sine square theta was already present on the left hand side. Let's subtract 3 both sides. Let's subtract 2 sine square theta both sides. Let's add 2, and then square root of 3 square root of 2 is square root of 6 sine theta both sides. Now we have an equation. We can further simplify this, whatever like terms are simplifying. So 1 and minus 3 will give me minus 2. Let's write that, and then these two are done. So then negative sine square theta, negative 2 sine square theta is going to give me negative 3 sine square theta. Alright, and then we have this term remaining, which is positive 2 square root of 6 sine theta. Alright, next we can multiply the whole equation by negative 1 to make the coefficient of sine square as positive. So we'll get 3 sine square theta minus 2 square root of 6 sine theta, and then plus 2 equal to 0. Then again, this equation is a quadratic equation in sine theta, so let's replace sine theta by a variable. Let's use z this time. So this will become 3z square minus 2 root 6 z plus 2 equal to 0. And then we can use our quadratic formula to simplify this. So z is going to be negative b, which will be positive 2 root 6 plus minus b square. So square of this is going to be 24, and then negative 4 times 3 times 2. So 4 to the 12, 24. So this will cancel out and we'll have just, so let's simplify this. We get z as, so this is 0, and then we'll get 2 root 6 over 6, which is root 6 by 3. So this tells me that my sine x is square root of 6 over 3, and my x is going to be the inverse of square root of 6 over 3. Let's calculate this value. So this comes out to be 0.955. Right, so this is going to be the solution for my equation. Alright, so this is my solution here, and I'll also get one more solution, which is pi minus this, but checking for that value, I think that value does not satisfy our equation. The next problem here, the number 11th, is the quadratic trigonometric equation cot square x minus b cot x plus c equal to 0 has the solutions pi by 6, pi by 4, 7 pi by 6 and 5 pi by 4 in the interval this. What are the values of b and c? Okay, so we know this is a quadratic equation in cot x and this has a particular solution, right? So one thing we can do is we can make our quadratic equation from the solutions, and then just compare the values of a and b. This is one way of doing it. The other way of doing it is we can substitute these values into the equation itself and form the form the values of b and c, right? So we can just substitute these values into the equation and then solve for b and c respectively. Okay, so let's start with this pi by 6. So what happens if I put pi by 6 into the solution? So it becomes cot square pi by 6 minus b cot pi by 6 plus c equal to 0. And we know that cot pi by 6 is same as tan pi by 3, which is root 3. So cot pi by 6 should be root 3 also. Yeah. So this becomes 3 or just root 3 square, and then minus b times root 3 plus c equal to 0. And we can solve this furthermore. We can say, alright, negative b root 3 plus c is negative 3, or you can say b root 3 minus c is 3. So this is one of the equation. Then we can use the next value, which is pi by 4. So same thing, cot square pi by 4 minus b cot pi by 4 plus c equal to 0, and pi by 4 is 1, so this will be 1 minus b plus c equal to 0, and then we can simplify this to become minus b plus c as negative 1, or b plus c, b minus c, as positive 1, right? So these are the two equations in B and C that we have. Now we can just simplify these linear equation in B and C. So let's just subtract both of these equations, and when we subtract, these C will cancel out and we'll get, so what we are doing is we are subtracting 1 and 2. So b root 3 minus b should be equal to 3 minus 1. So we can take b as a factor, and this will become root 3 minus 1, and then this will be 2. So the value of b comes out to be 2 over square root of 3 minus 1, and the value of a, we can just use any of the equations. So let's use the second equation, the value of c, for the value of c. So 2 over square root of 3 minus 1 minus c is 1. So here the value of c should be 2 over square root of 3 minus 1 minus 1, and then this is going to be 2 minus square root of 3 plus 1 over square root of 3 minus 1, which is same as 3 minus square root of 3 over square root of 3 minus 1. Alright, so these are the values of b and c. One thing to note here is, if you look at this value, this is not a rational value, so we can rationalize this denominator by multiplying this by square root of 3 plus 1, so that this becomes 2 times square root of 3 plus 1 over 3 minus 1, which is just 2, and then these two will cancel out to give you the simplified value of b as square root of 3 plus 1, right? So we could have used that value also, and that would give you the value of c as square root of 3, right? Or you can rationalize this value also, so square root of 3. So what we are doing is we are multiplying by square root of 3 plus 1, and that will give me 3 root 3 plus 3 minus 3 minus square root of 3 over 3 minus 1. Now further simplifying this, these 3 will cancel out, and then 2 root 3 over 2, which is same as square root of 3. So the value of c came out to be square root of 3, and the value of b comes out to be square root of 3 plus 1. Right, so these are my b and c values. Okay, we can also check that our solution is correct or not by putting this back here and then checking with the other values. But the other values that are here, 7 pi by 6 and 5 pi by 4, are the co-terminal values for these particular angle, pi by 6 and pi by 4. So you can use any of the 4 values to really get your answer, right? But since there are only 2 variables, you only need you need to make 2 equations to solve for these 2 variables. Alright, so let's start. Given that fx equals tan x over 1 minus tan x minus cot x over 1 minus cot x, determine all the values of a in the interval 0 to 2 pi such that function equals tan x plus a. Okay, so we know that function will be this value, so what we can do is we can write this as tan x plus a as tan 1 minus tan x minus cot x over 1 minus cot x. Alright, next what we'll be doing is we have to simplify this right hand side so that this becomes a single tan function, so that what we can do is we can compare both of our sides and we can find out the value of a. Alright, so for this we'll be using the tan x plus y identity, and but before that we need to simplify the right hand side a little bit. Alright, so let's start by taking the LCM. So here the LCM should be 1 minus tan x times 1 minus cot x, and then when you do this you'll get 1 minus cot x times tan x, and then minus 1 minus tan x times cot x. Alright, let's simplify. Let's open the brackets. We have tan x minus tan x cot x minus cot x, and then negative is this positive tan x cot x. Alright, and then this value when multiplied is 1 minus cot x minus tan x, and then plus tan x cot x. So these can be cancelled out, and we have in the denominator this tan x plus cot x is going to be 1, because when you multiply tan and cot, they should give you 1, as tan x is the reciprocal of cot x and vice versa. So this is 1 plus 1, I can write this as 2, and then we'll get tan x minus cot x. So since I need to write this entirely in tan x, I'm going to write this cot x as 1 over tan x, and then whole over this 1 and this 1 is giving me 2, and then negative 1 over tan x, and then minus tan x. So I'll be taking the LCM one more time in the numerator and in the denominator. So if I take in the numerator, I'll get tan square x minus 1 over tan x, and in the denominator I'll get 2 tan x minus 1 minus tan square x over tan x. Right, so in the next step we can just cancel out this tan x, and we are left with tan x square minus 1 over 2 tan x minus 1 minus tan square x. Okay, so let's further try to simplify this. In the denominator we are getting a quadratic equation in tan x, and so in the numerator I'm going to use the difference of squares, which is giving tan x minus 1 and tan x plus 1. In the denominator I'm going to factorize this quadratic equation, and I should get, what should I get? I should get tan x minus 1 and then whole square. Right, so if you expand this, you'll get tan square x, you'll get plus 1, and then you'll get negative 2 tan x. So I should also take a negative out from here, which is this, and then it's the same. Okay, so just to be careful, I have taken this negative out, then it became the whole square. Alright, so I can just cancel this and this, and I'm left with 1 plus tan x. Okay, let's write this as 1 plus tan x and 1 minus tan x. Now this looks like nothing, but this is actually the formula for tan 45 plus theta. Now what I'm going to do is I'm going to write this 1 as tan 45 degrees, or you can use pi by 4 minus tan x over 1 minus tan. If I write pi by 4, it doesn't make any difference, because tan pi by 4 is just 1, and 1 times tan x is tan x. Now this form that you have is the form for tan a minus b. Now let me write the formula for tan A minus B. So we know that tan A minus B is tan A minus tan B over 1 plus tan A okay, so this is plus, not minus, my bad. This is plus and this is minus. Alright, so then this formula comes out to be the formula for tan A plus B, not minus. So this is A plus B, tan A plus tan B over 1 minus tan A tan B. So this is the formula for tan A plus B. Now if you compare this, the above equation that we got for tan x plus A, so this is tan pi by 4 plus tan x over 1 minus tan pi by 4 and tan x. Now if you compare both of these, A should be x, not x, pi by 4, and then B should be x, right? So we can compare both of these. We can say this right hand side, using the formula that I've just written, we can say that the right hand side is same as tan pi by 4 plus x, right? So this is the expansion for tan pi by 4 plus x, and if you compare both of these functions, now you will say that x plus A is same as pi by 4 plus x, which tells you that A should be pi by 4. Alright, so this was all of the questions for today. I hope you understood all of them. If you have any questions, you can comment down below and I will get back to you as soon as I can. Thank you for watching. Have a great day. Bye bye.